Hello, welcome back to my second lecture about the operators. In a previous video, we have seen the arithmetic, comparison, assignment, and logical operator. In this video, we will discuss the membership operator, identity operator, and bitwise operator. I am from the Salesforce dealer scene, so let's start. So if you get more information about operators, so visit to our website sales.com. Okay. After the opening this web page, go to into the Learn Python section. It's the Learn Python section, and then visit to operators. Now we will see the bitwise membership and identity. Okay. So first we will talk about the membership and identity, and again discuss about the bitwise operator. So membership operator first. Open the ideally. If I take the string hello, how are you? Okay. So is hello in A? It's true. OW in A. It's true. Here is a exist this string. Hi, not in A. True. Hello in A. False. Because here is a H is in a capital letter. So again I taking a list. 543 in A. True. In A. False. Okay. So here is a example of in or not in. Okay. So next is that is the identity operator. In the identity operator, we use the is and is not. So let's take the example. My string is my string. True. If A is equals to hello and B is equals to hi, it's a hello in a lowercase. A is B. False. Because H is in a lowercase. Okay. So if you notice that here is a work as a double equal operator. See, 34 is a 34. True. But what is the difference between a comparison operator and the identity operator? Both are working as the same, but here is a difference. L- Look at out. True. But now this is so the false. Why? Because is is operator is checking by the ID. But in the case of comparison operator, double equals to the check by the value. If A double equals to B, then it is true. If A is B, then it's false. You can see that here is the ID as a different of the A and B also. Here is a in the last you can see the six zeros 60593040, but in the case of B, the 605930 and 8. So that's why it's given the false. When you assign the number in a less than 256, then it's given the same ID. So that is why it's given a true 254 and B is a 254 and A is B is true. If ID is A and ID of B, okay. So here you can see that is the ID as same, so that's why it's given the answer is true. Okay. So here is the identity operator. Now we will be talk about the bitwise operator. So in a bitwise operator, we will talk about a co- complement and operate and bitwise or XOR. It's the symbol of XOR is the cap. So let's it. It's a tight shift. First, we will be talk about the complement. If I take the number 10, it's complement 10. So what will you expect the answer? It may be 1, 2. What is you expecting? It's minus 11. It's a weird now. Why is the minus 11 is shown? Okay. So let's find out the answer of this question. So open the notepad again. Okay. Now, what is the binary of the 10? 1, 0, 1, 0. Okay. If you want to get the binary of the 10, you can also use a bin function. See, is a 1, 0, 1, 0. Okay. So let the inverse of this number is a 1, it's become 0. It's this one is become a 0. This 0 is become a 1. Is 0, it's 1. Okay. So what of this number? So here is my answer is that the minus 11. Okay. So let's check. Let's check of the minus 11 because your system does not storing your negative numbers. It's only store your positive number. So now I will be convert this 11 into the binary form. So 1, 0, 1, 1. Okay. Here is a binary number of 11. So now we will find the 2s complement. Okay. Now we will find the 2s complement of this binary. It is a it is 11. Okay. So before we find out the 2s complement, first we find out the first complement, one complement. Okay. So one complement first. So let's get the inverse number of this binary. To get the first complement is a 0, 1, 0, 1. Okay. It's a 0. Okay. So now again we have find the 2s complement of this number. So adding the 1. Okay. Now we will get the answer. So here is 0, 1 is 1. Here is a 0. It's a 1 and it's a 0. Okay. Now you will see this number are the same as the number of this. So that's why you get a 11. Okay, try out with a different number. Okay, so that is the reason to get the element. So here is the complement. Okay, now we will talk about the binary of, it's a AND operation in bitwise operator. Okay, so here is a bitwise AND. So we are taking the 12 and 10. So tell me the answer of this bitwise AND. So here is the 8. How we will get the 8? So let's see. So what is the binary number of 12? So 1100. Okay, it's the binary number of 12, and 10 is the binary number of 1010. Okay, so now we will be perform the AND operation of this binary, because it is a bitwise AND. So we have get the bit of this number 12 and also get the bit of this number the 10. So here is the bit, it is a 10, it is 12, and it is a 10. Okay, now we will be see the bit of the AND operation on this number. So 1 is become 1, 10 is become a 0, it's a 0 and 0. Now it is a 8. So that is why we have get the 8. Okay, now next is that bitwise OR. Okay, it is a bitwise OR. So 20, it's a 10. So what is the bitwise OR? Is 30. How we get a 30? Let's see. If we if you want to find out the binary number, again I say it's using the bin now. Okay, get the number and press, you can see the binary number of this number, of this number. Okay, so here is, you can see it's a binary number is that. Okay, it is a 20. Now it's a 10. What's 10? 1010. Okay, it is 10. Now we will the find the OR operation between this bit. So find the OR. So 10 is 1, 10 is a 1, 10 is 1, it's again 1, is again 1 is 0. Okay, so that is numbers that is a 30. Okay, so this is the bitwise OR. Now we will be see the XOR. Okay, so again we taking XOR. So again taking the 12 and XOR 10 and 5. See the sixth number. Why it's sixth number? Let's see. It's 12 is that 1 0 1 0. Okay, not a 10, 1 0 0. Okay, it is a 12, and find a 10 is a 1010. Now find the XOR of this bits. If left and it's a if this one and here is a different, then it will be a, given the 1. Otherwise this number and this number is the same, it's given the 0. So here is a 1, is 1 is same, so we have 0. Here is a different, here is a 1, is a 1, here is a 0. So this number is the, so 6. Okay, so where we can find the XOR. Now we will talk about the let shift of number. If I taking the 10 and let's shifting by 2. Okay, now we'll get a 40. How we'll get a 40? So let's see, this 10 is that is 0 1 0 1 0. Suppose it is a point, it's a number. Okay, in a decimal you also think that is, it's a after the point is the, it is nullable, and 1 2 3 4 is the my real number. So that's why we are also the taking like that in the binary form. So 10 I'm shifting the 2 bits into the left side. Okay, so here this number will become at this side area. Okay, now it will be it's a 40. Okay, so this number is the 40, so we can get the 40. Okay, after it's right shift, if you talk about right shift, two is a 2. Why? The 1010. Okay, if we are after that we have the decimal here, we has assume that if you are shifting the 2 bits at this area, so it will be erased, then only it will become a 01. Say number is that 2. Okay, so we have get the 2 number. So that's all for this session. I hope you learn lots of things from this video. So thanks for watching video. Thank you.